So very good afternoon to all. In unit number 3, DC to DC converter, we are in the last segment. The last segment is application of converters in battery operated vehicle. So whenever you say battery operated vehicle, the end motor has to be controlled for various speed from the existing battery which is available. So you have to increase the voltage or decrease the voltage depending upon the requirement. You will try to boost or buck. So obviously converters plays the role. So large number of automobiles in use around the world has caused a continuous and serious problem of environment and human life. Air pollution, global warming, rapid depletion of earth petroleum resources, and more serious problems. Okay, electric vehicle, hybrid electric vehicle and fuel cell electric vehicles has been typically proposed to replace the conventional vehicle in near future. The most electric and hybrid electric configuration uses two energy storage device. Okay, so that we called hybrid with respect to the energy itself. One with high energy storage capacity called main energy system, that is battery. So battery we call it as MES, and the other with high power capability and reversibility, which is called rechargeable energy storage system, we call it as RESS. In some case, when you use the existing petrol or diesel, then that comes under MES, and if you put additional battery, then it becomes RESS. In some case, main energy system will be battery, RESS will be like fuel cell or super capacitors. So for any sudden increased thrust you need, sudden pickup, all such you need, you will go for some additional thing which is rechargeable type. That will not be continuously run, whereas it will be charged and used at a particular point of time, and some point of time even it will get charged. Okay, for example, we have seen bidirectional converters. So bidirectional converters, I have told, it will transfer from source to load as well as from load to source. So if you are coming from top of the Tirupati to bottom, at that time I can generate energy and I can store it in battery. Okay, all such things can be done. Now DC to DC converter can be used to interface the element in the electric powertrain. Powertrain is nothing but, why we call it as powertrain is power flow from one to other, power is flowing. So that flow of power is controlled by converters, and that process we called as powertrain. By boosting or chopping the voltage level, the power converter structure has to be reliable, lightweight, small volume with high efficiency, low electromagnetic interference and low current voltage ripple. Now this is your electrical vehicle powertrain. So powertrain, I have told, no, you can use battery, or you can use super capacitor or fuel cell. Okay, and this may be main and this to be auxiliary. So when you use main, again you have to step up and step down because to increase the speed. Okay, in some case even the motor will be an AC motor, where I should have a conversion from DC to AC also. Okay, but the input voltage to this DC to AC I can use with the help of converter. So if to the required AC voltage magnitude I can step up and I can give. There are some motors like BLDC, brushless DC motor. This is a DC motor but operates on AC principle, which means you have to give high frequency AC supply. So for that only you use this DC to AC conversion. Okay, this is electrical motor, this is transmission like gears and all. Okay, so either you will power front wheel or back wheel. There are some cars with front wheel drive and there are some car with the back wheel drive. Similarly, even in your normal car also there are some car which is going for back wheel drive. So when you take Toyota and all, Toyota Innova, Krista, Qualis, all such things are back wheel drive. Like Maruti Wagoner, Maruti cars, it is even front wheel drive. Okay, so what I mean to say is, from your power supply you require DC to DC converters and DC to AC converters also. So different configuration of EV power supply shows that at least one DC to DC converter is necessary to interface the battery or the supercapacitor module to the DC link. Then there is a bidirectional converter can move the power in either direction, which is used for application requiring regeneration braking. The amount of power flow between the input and output can be controlled by adjusting the duty cycle. All this we have seen. So we have seen about converters. We have even seen simulation of converters also. So in the simulation of converters, I have shown you, when you simulate, I have shown you, by varying the pulse width. But the pulse width you might have seen, I have given 50, 60, 70, 80, like that. If I increase the width, obviously the output voltage will increase. Okay, so that is what we say it as duty cycle. Usually this is done by control the output voltage, the input current, output current, and to maintain constant power. The thing you have to remember always, power remains constant. Okay, from the source to load, if I step up voltage, automatically current will come down, and if I step down, automatically current will increase. Okay, so transformer based converters can provide isolation between the input and output. These types of converter we have seen in the last class with a 5-back converter. In a flyback converter you use a transformer. Why you want to go for transformer is, there is in a converter where I need isolation also. I may boost to very high level and give it to my drive system, and it should not come back. Okay, that may damage my source. So based on this, there are two types of converters. One is called non-isolated, another one is called isolated. Even this we have seen. A non-isolated converter type generally use whether the voltage needed to be stepped up or down by relatively small ratio. Because in non-isolated I don't have transformer. If I am not having transformer, step up and step down is done by the inductor and the capacitor alone. So the inductor and capacitor can help in stepping at maximum to the 4% of the input. Beyond that we cannot do. So there are various types of non-isolator like buck converter, boost converter, buck boost, and choke converter. Buck converter is used for voltage step down, while boost converter is used for voltage step up. Buck boost and choke can be used for both the purpose. Some person they will call it as choke. So okay, that is the right way. You should not call it as chuck and all. CUK is choke. It is a person name. It is a Japanese person name. It is kept on behalf of his name. So you have to pronounce it as only choke. Then comes isolated. We all know whenever you go for any transformer, then automatically it is called as isolated. So all these converters can be used as a bidirectional converters, and the ratio of stepping down and stepping up the voltage is high when you go for transformer based. Okay, what are the basic requirement of an electric vehicle with the help of converter? When you talk, whatever you do, converter weight should be very light, but the efficiency should be very high. Efficiency means losses. So you have to go with some semiconductor device which has high efficiency. Small volume, light weight, there is a difference, small difference. Weight should be less, and the occupancy of the converter also should be small. Then comes electromagnetic interference. I think when you keep any, how to visualize this is, take a magnet and bring this magnet near your TV. You can see some color change, and this color change is because this electromagnetic interference. There will be always an interference between magnetic field and electric current. We all know it is related in BH curve itself. So if there is any leakage of your magnetic field, where these magnetic fields are generated is when you use inductor. When you use inductor in your circuit, The inductor, it is wound on a dielectric, so automatically electrical field will be converted into magnetic, and this magnetic starts travel, and if this magnetic come in contact again with the electrical, then we will call it as electromagnetic interference. Current ripple should be very less. Step up function of the converter, control of DC to DC power flow subjected to wide voltage variation. So I should go with 10% to 100% variation, then only the speed, the transition of my electrical vehicle will be very smooth, or it will jump from one speed to another speed. So block diagram of control mode, we will go for control mode with the two loop, one loop for voltage and one loop for current. You can see here, from the converter output I have taken both voltage as well as current. The outer loop we call it as voltage loop, and the inner loop we call it as current loop. So both you will go for closed loop operation. As per the requirement only, the output of the converter should be connected to an electric motor. So I cannot say I will control voltage and leave about VI, all that is not possible. Both current control and voltage control is required. Okay, so I think now to achieve accurate voltage regulation, two control loops are used. Okay, one control loop is for voltage and another one is for current. Okay, so this is with respect to this, we will try to wind up. So today's class we have seen about the application of converters.